All right, so let's say that you have an area in the tail of a distribution, in this case in the tail of a standard normal distribution. So maybe area over here in the left-hand tail, and you know that this area is 0.05, and your goal is to find the z-score, that's the dividing line, that separates this 0.05 from the remainder, well, which would obviously be 0.95 because those two have to add up to 100. How can we find this z-score? So the answer is to use another function from our distribution menu. It's option number 3, which is the inverse norm function. So inv norm. And this function has 3 arguments, so 3 pieces of information that you'll need to enter. The first is an area to the left, and then mu and sigma. For the standard normal, these are always going to be 0 and 1. So I can put in 0.05, comma, 0, comma 1, and the result is going to be a z-score. Now it's not surprising that this is a negative z-score because all the z-scores to the left of center are negative, all the z-scores on the right are positive. So this is negative 1.64, let's if we go one more decimal place, negative 1.645. Let's say that we want to find the z-score that separates off the top, let's say 20%. So what's the z-score? That's the dividing line here. So the key, one thing to remember is if this is the top 20, that means that there's an 80 over here on the bottom. So we're looking for that dividing line, the split between the 80 and 20. So once again, I'm going to use inverse norm. Now, because my calculator is set up for area to the left, even though I originally asked for, phrase the question in terms of the top 20, I'm going to rephrase it in terms of the question of the bottom 80. And so, because my calculator wants area to the left, I'm going to use 0.8. But notice it's the same line that separates the bottom 80 from the top 20. So I'll use 0.8, 0, and 1. So I'll go back to my distribution menu, choose option 3, 0.8, 0, 1, and that z-score is 0.842. I'll keep this at 3 decimal places. And that makes sense because I knew it was going to be positive because it had to be to the right of 0. Remember, 0 is the 50-50 line. And I was looking for an 80-20 split, so it had to be somewhere to the right over here. What if we want to isolate maybe the middle 50%? So the key here is to think, again, if I'm going to use the inverse norm function in my calculator, I want to find a dividing line for in terms of area to the left. So if this is the middle 50%, and I know that the total area is 100%, then how much is in each of these? They have to add up all of these values. I've kind of divided up my curve into 3 segments. There's this segment here, the middle 50, and then this segment here. Now, together, the 3 of those, I'll call this segment 1, segment 2, and segment 3. That's the entire curve. Now, if I know that the middle here has area of 0.5, 50%, and if I think about removing that, then that leaves another 50%. But half of that is on the left, half of it is on the right. So if I take 100% and subtract off that middle 50, I'm left with 50%, but that has to be split between the left and the right tail. So that means there's 0.25 here and 0.25 here. Again, all 3 of those together give me 100%. So what's the line that separates off the bottom 25%? I can use inverse norm, 0.25, 0, and 1. Inverse norm, 0.25, 0.01. And the z-score on the left-hand side is negative 0.674. Now what about on the right-hand side? Where's this dividing line? So you've got two options here. One is to recognize that this is symmetric, and all I need to do is to change the sign to positive. That is the easiest thing to do here. Now that works because the center here is 0, and but if that were not the case, we could also realize that this is the line that cuts off the bottom 75%. So if I take this 25 plus this 50, that would be 75%. So I could also use inverse norm 0.75, 0, and 1. And just to show you, let's see, here's my distribution, option 3, 0.75, 0, and 1. And you'll get the same thing, positive 0.674. Let's see. Another way to think of this, if you wanted like the 75th percentile of z-scores. So a percentile separates a bottom percent from a top percent. In other words, it's separates the bottom 75 from the top 25. So I'm looking for that cutoff where it's 0.75 to the left and 0.25 to the right. And that's what we just found here when I said that we could use inverse norm 0.75, 0, and 1. If you'd wanted the 80th percentile, you would just use 0.8. If you wanted the 95th percentile, you would just use 0.95. So asking for a percentile is just another way of asking for the basically the area to the left, or the z-score that separates a certain area to the left. And finally, I want to mention something that is going to come in handy when we talk about hypothesis test. There's a notation where we say z with a subscript of alpha, and alpha is area in the right tail of a standard normal curve. So for instance, if I said z and then 0.05, I'm looking for the z-score that separates off 0.05 in the right tail. Now again, that would mean that there's 0.95 to the left, and so to find this, I'll use my inverse norm function, 0.95, 0, 1, and that is 1.645. Recall, we could have also noticed that that's the value that puts 5% in the left tail. The opposite of that is going to put 5% in the right tail. So those are, that is how we use the inverse norm function. So these questions, we are starting with an area or probability, and we're trying to find a z-score. All right, I hope that helps. In another video, we'll be looking at normal distributions and applications of the normal distribution where we don't necessarily have a standard normal distribution. I hope you'll join me.